What's up everyone, welcome back to my channel. Today we're going to work on a trigonometric equation and try to find the expression, namely sine square of x plus cosine square of x equals 1. And as we know from trigonometry class, this will work for all real numbers x. So this time, let's try to find out what happens if we try to extend the variable x into z, or where z could be any complex numbers. And in this case, we will just need to focus on any non-real number, such as I or 1 plus 2i, something like that. And again, that's because we have already known the results of when x is equal to some real numbers. So as long as we can just find out the expression for non-real numbers z, we can just combine them together and say that what happened for all the complex numbers. So before we move on to the solution, you can pause the video and try it yourself first and take a guess what happened if we try to extend it to the complex world. Alright, are you guys ready? So here we go. For this problem, we actually need to use some ideas for complex numbers. Such as, if we write a complex number z, we can always write it as the real part plus the complex part. Or we can just write as x plus iy. For some people, they will use a plus bi. They just mean the same thing. A, b, x, and y are what we call the dummy variables. But if we think it on the graph, we can just make x and y be the axes on the graph for the complex number. So let's stick with it. For some people, you perhaps already know that we can write as in polar form as well, which is r times ei theta, where r is defined the radius, or also known as the modulus of z, which could be defined as the distance between the point z, or the complex number, from the origin on the 2D plane. So we can just rewrite r as the square root of x squared plus y squared. And again, that's just based on the distance formula in 2 dimensions, where the theta here is defined as the angle, that how much the point is rotating from the positive x direction when we try to graph it, so that we have something like this. For example, if z is at this point here, then theta will be the angle from positive x direction rotating up to where z is on, and we will just pretend that there's a ray right here. So this will be our theta. Then numerically, how do we find it? By drawing a line here, we actually form a right triangle. So we can just use the trig identity. If y is a vertical distance and x is the horizontal distance, we have tangent of this angle theta be opposite over adjacent. So in our case, it will be y over x. And we just need to take the inverse of the function, meaning that we're going to take arctangent of y over x to give us the result. Good. And of course, if the points are actually on the 3rd quadrant and the 2nd quadrant, we just need to add pi over, we just need to add 1 pi or 180 degrees to adjust the angle. And that's how we define in polar form. And also, for some of you, perhaps have already taken complex analysis, or maybe just in the Calculus 2 class, you have heard that we can use Taylor series to help us to rewrite the polar form as well. Meaning we can just rewrite the part e to the I theta into the following, using the Euler identity, which is cosine of the angle theta plus I sine of theta. So for this problem, we're going to use the identities down here to help us getting the result. How do we do it? Here we go. So we can actually make a direct proof here, or a direct solution. Starting off with sine square z plus cosine square of z. Keep in mind z is complex numbers, or actually non-real numbers. So what can we do? We can actually break, first we can rewrite the order into cosine square plus sine square. Now, we don't want to say that as 1 yet because we actually don't know whether it's true or not. So here we get cosine square of z plus sine square of z. Then we can actually use the difference of square formula. But how do we do that? Remember, distance of squares formula says that a squared minus b squared equals the sum times the difference. But we don't have a minus sign here, we have a plus sign. What can we do? Of course, we can just take out a -1 so that it'll balance out. And what is -1? Well, by definition, -1 is just I squared. It is the imaginary unit squared. So we can in fact rewrite it as cosine z plus I sine z times cosine z minus I sine of z. Good. So if we look at the first part, using the Euler's definition, Euler's identity, we can just rewrite this as e to the I z, where z is again the angle that we have here. For the second one, we are going to use some little trick here. We're going to put the negative sign for the imaginary part into the angle, and again that's just following from the property of sine function. We know that sine function is an odd function, meaning if we try to pull out the negative from the output, we have to change the input with a negative. And it's the same to think the other way around. If we have a negative in our input, we can just simply take out the negative and pull it out. So now we just need to adjust our cosine function. But cosine function is even, so if we have a negative input, it will be the same as the positive input. We just simply put a negative in the parentheses part, like this, so that it will still be the same as what we have here. And therefore, if we now look at here, it will still be the same as what we saw for the Euler's identity, except now, instead of having a positive angle, we have a negative angle. So that, if we rewrite it, we'll get I times -z. And last but not least, we have the same base. We can just use the exponent property. We will just add the two exponents together to get iz plus I -z, which is same as minus iz. And ladies and gentlemen, we get 0 in our exponent, which is, by definition, e to the 0 power is just 1. And therefore, our answer is sine squared plus cosine squared is also equal to 1 even if the angle or the input that we have becomes a complex number. All right. Pretty cool, huh? So if you enjoyed this video, don't forget to like, and you can also subscribe to my channel so that you can find more of my other videos, and you can also turn on the notifications so that you don't miss any of my new videos either. If you have any thoughts, you can leave your comments below. I'll see you guys in the next video.